I'm Christiana Smith and I'm from Carmel, California. I'm currently in my final semester in the Master's in Management Information Systems at the University of Alabama.
Hi, I'm Howk. I'm originally from Fort Collins, Colorado, and I'm a senior in the Accelerated Master's Program in Management Information Systems at the University of Alabama.
Hi, I'm Skyler Lynch. I'm originally from Holland, Michigan, and I'm a final semester graduate student in MIS here at the University of Alabama.
Hi, I'm Joshua Pachares. I'm from Nashville, Tennessee, and I am in my last semester of the Master's of Science in MIS program here at the University of Alabama.
Our project is focusing on the United Nations' third Sustainable Development Goal, good health and well-being. This goal focuses on promoting healthy lives and well-being for all at all ages. With child health and maternal health being at the forefront of this goal, our project is targeting a very important issue.
Sudden infant death syndrome, or SIDS, is one of the leading causes of infant mortality, with 3,500 deaths yearly in the U.S. alone. Many of these deaths are concentrated in low-income rural areas such as Alaska, Alabama, and Mississippi.
Protective childcare, especially early in development, can be very expensive, but it can have a lasting impact on a child's entire life. We believe that by finding an affordable, low-cost solution to sudden infant death syndrome, we can help save hundreds, if not thousands, of lives in the U.S.
The solution is SleepSafe, a baby monitor application that uses a neural network to determine if infant sleeping positions and environments are safe or unsafe, using a bank of predefined images. This technology is made possible by using the NVIDIA Jetson Nano.
A neural network is a series of algorithms that analyzes a data set to find underlying patterns, mimicking the way the human brain works. We are using computer vision, which is a subset of artificial intelligence, which trains a computer to interpret and understand the visual world.
In order to train our model, we compiled a data set of pictures of babies sleeping in both safe and unsafe situations. We found these pictures using the internet, as well as created pictures using a baby doll and Photoshop. These pictures were meant to convey a wide range of different camera angles, as well as different positions and different props within the environment.
Now we'll look at a technical demonstration of our solution.
To create and train our model, we used a JupyterLab notebook which runs Python and is provided by NVIDIA in the form of a downloadable Docker container for use with the Jetson Nano. After setting up the Nano in headless mode, which means it can be run without the need for a keyboard and mouse input if paired with another processor like a laptop, we set about collecting our dataset. In the notebook, there is a file titled sleepsafe_a, which is where our training images reside. Inside of the folder, there are two categories, safe and unsafe. These are determined based on CDC guidelines for preventing SIDS. Inside of each folder, we have many images, but here are a few examples. This image would be considered safe and is in the safe category because the child is sleeping on its back in a relatively firm crib with no obstacles in it. This image would be considered unsafe because the child is sleeping on its stomach in a relatively soft sleeping environment, which could cause suffocation. After collecting our data set, we run through each of these cells by pressing Shift and Enter, changing any fields that we need to for our specific use case. Down at the bottom, there's an interface that we interact with. As you can see, there is a dataset button here labeled A. That's because we have selected the SleepSafe A dataset. Categories allow us to select a category for each image that we would add if we wanted to use a live image to train the model with the Add button, which is connected to a webcam that you could use. Count denotes how many images are in each category. We have elected to use 42 and 42 to keep things synchronous, but you can easily increase this number by adding more photos and then training the model based on those. The epochs box denotes how many times we want to run the model over the training data set. The higher the epochs, the more accurate the model can become on the training data, but the longer it takes to produce a model, so we elected to run about 15 epochs. The progress bar shows the amount of time left in epochs. It's already full because we've already trained the model. Loss is the error calculated in training, and accuracy is the percentage that the model chose the correct category during training. The train button and the live button are what we will move on to next for a live demonstration. After hitting the train model button and moving through all of the epochs and hitting live, I will open the webcam and we will see an image of a baby on screen. The model is predicting that this baby is in a safe sleeping position, which it is. The child is sleeping on its back in a relatively safe, firm environment with no obstacles in it. We can move on to an example that would be considered unsafe, and as you can see, the model accurately responded. This child is sleeping on its stomach in a relatively soft environment and would be considered unsafe. It should be noted that these images are not included in the training dataset. We specifically omitted them so that we could use them for testing purposes later. So the model is accurately guessing based on what it already has in its training dataset. I will now close the camera and discuss the last two buttons, which are Load and Save Model. Load Model allows you to load a previously trained model, and Save Model allows you to save one to a thumb drive, or in our case, an application. We would use this model to move to our application and use in real-life processing. We foresee the model could become more accurate in the future by providing it with a more varied data set and with more training data in general. And once the model is as accurate as we would want it, we could export the model to our application and use it in real time.
And now we will go into a demo of our user interface. First, the app will load the splash screen featuring the SleepSafe logo, and then it will move on to the first Get Started page. Once we click the next button, we can go ahead and sign in or sign up for a new account. We'll go ahead and enter all of our information here in order to sign up for a new account. Then we can click Continue and move on in the setup process. On this screen, we can connect our Bluetooth camera. Once we make sure it is on and in range, we can go ahead and move on to the next screen. Here, we'll make sure that the camera is installed over the crib in a position where you can view an aerial view of your baby sleeping. Now that that's all set up, we are ready to start using the app. You can see here a live view of the baby's sleeping position, and the neural network will be able to, in real time, identify if the sleeping position is safe or unsafe. You can see here that this is a safe sleeping position. Therefore, no alert will be sent. However, if your baby shifts into an unsafe sleeping position in the night, as seen here, the neural network will identify it as unsafe and send a warning to your phone. If we click View Alerts, you can view a breakdown of all the recent alerts and warnings, as well as getting a push notification to your phone each time a warning is sent. We can also view our profile, where you're able to update your preferences, privacy settings, and other settings. There's also a statistics page where you're able to view your alerts and warnings in the past week, as well as the amount of sleep your baby is getting each night. While other research has been done on the application of AI to baby sleeping position, ours provides a practical approach. Additionally, our model has been up to 95% accurate in testing, which is more accurate than other solutions on the market.
Other solutions often use vital sign monitoring, and while that may look enticing to first-time parents, SIDS has no actual physical warning signs. Our solution is innovative in that it uses baby position, a more accurate predictor of SIDS, in order to create our model.
Our target audience is new parents, especially parents to male infants and Native and Black infants, because they have a higher likelihood of being susceptible to sudden infant death syndrome. To further technical capabilities, the team at SleepSafe could work with infant behavior specialists and doctors whose expertise could help the team fine-tune their neural network, leading to proactive treatment of such afflictions.
The next steps of our solution would be to partner with organizations that have a vested interest in child and maternal care. Nonprofits like UNICEF, CARE, and Toys for Tots could help expand our reach and connect families that need resources to those resources.
A second solution would be to partner or sell our product to a current industry leader in infant care and overall child care, such as Johnson & Johnson and Procter & Gamble. Most first-time parents fall between the ages of 26 and 30, and this age group spends on average 2.5 hours on social media every day. So we want to invest time into creating social media ads that would be highly visible due to the amount of time they spend on social media.
From the SleepSafe team, we thank you for your time and consideration.
We believe SleepSafe has real power to promote change in a vulnerable community.
By utilizing the power of neural networking, we believe we can dramatically reduce the number of infant lives lost to SIDS every year.
If given the opportunity, we believe there is potential to improve upon and expand our solution. Thank you so much for your time.